Okay, this is the P4 paper from October 2020. This is question number 8, which is a vectors question. As we can see quite clearly here, we're going to be finding a point of intersection. But the second part B, in order to do that, we're going to have to solve some sort of geometrical problem in 3 dimensions. So let's have a look at part A, because part A is relatively straightforward. We've got these lines L1 and L2 that are going to meet at some point X here. I don't need to draw a diagram for that, so I'm actually going to get rid of that at the moment. I will do later on, but for that, this is a fairly standard technique. What I'm just going to do is put the 2 equations equal to each other. So I'm going to say L1 is going to equal L2, and then for L1, for example, I'll get 4 plus 3 lambda is equal to 2 plus 2 mu, and so on. Well, let's actually show you rather than just doing it on here. So part A, I like to try and use the same sort of language each time, just give the examiner some confidence in what I'm doing, and also I think I'm less likely to make mistakes. So I would say if they meet, then there is a point X, Y, Z. There is a point X, Y, Z, so that X, Y, and Z are equal to, well, X will be 4 plus 3 lambda equaling 2 plus 2 mu, and we just carry that on all the way through. So we will say 4 plus 3 lambda is equal to 2 plus 2 mu. We'll say minus 3 minus 2 lambda is equal to minus mu, and we'll get 2 minus lambda is equal to minus 9 minus 3 mu. So I've got 3 equations here, and what I need to do is to solve 2 of them simultaneously, completely ignoring the third one, solve 2 of them, and then it'll always work for the first 2, sub your values into number 3 to see whether it works for the third equation as well, and if it does, then the lines meet. If I am doing this in a relatively standard way, I just tend to pick the top 2 equations and just try and solve those 2, and then check it in the third one. So solving for equations 1 and 2, let's have a look at those 2 then. I've got 2 mu there and minus mu there. So actually, if I now, let's get rid of those bits there. If I now multiply that one by 2 here, I'm going to get 4 plus 3 lambda equals 2 plus 2 mu. And doubling up the second one, I'm going to get minus 6 minus 4 lambda is equal to minus 2 mu, and I've done that so I can now add these 2 equations together and the mu's will cancel out. So adding those together, I'm going to get minus 2 minus lambda is equal to 2 there. That rearranges to give me lambda equals minus 4. I've now got to work out what mu is, and I must use one of the top 2 equations. I can't use equation 3. I'm ignoring equation 3. So if I've got 4 plus 3 lambda is equal to 2 plus 2. If I've got that one, all I'm going to do is just stick lambda equals minus 4 in there. So I'll get 4 minus 12 is equal to 2 plus 2 mu. And then again, rearranging all that, mu works out to be equal to minus 5. And as I said earlier, I knew I was going to get those 2 answers there. I knew that we're going to get 2 values here that were going to work. I haven't shown anything yet until I check it in the third equation. So check in equation 3, and then if there is a point of intersection, then in equation 3 it will work out. So equation 3 says 2 minus lambda is equal to minus 9 minus 3 mu. Well, that works out to be 2 plus 4 is equal to minus 9 plus 15, which works out to be 6 equals 6. Therefore, they do, therefore they do meet. What's the point of intersection? Now, do I want the point of intersection? No, I want the position vector of X. So I can either use the lambdas or I can use the mu's to work out what X, Y, Z are going to be. It doesn't matter. I'm going to choose to do, which one shall I do? I'm going to use the lambdas. So 4 plus 3 lambda minus 3 minus 2 lambda, and then minus 2 minus lambda, where lambda was equal to minus 5. So was it minus 5? Yeah, lambda was equal to minus 4. So that works out to be minus 8. That works out to be 5. And that works out to be 6. So that's part A done. That's the position vector of x. For part B, it says P lies on L1. Okay. Q lies on L2. If PQ is perpendicular to L2, can we calculate the coordinates of Q? Gosh, quite a bit of work to do there. First thing I really need to do is to just draw that out to give myself an understanding of what I've got going on. So what we've said is that we've got these two lines, L1 and L2, that just meet somewhere. So I'm going to say L1, oops. L1 is that line there, and I'm going to say L2 is this line here. We know that they meet X there. That's not actually that important. I can put it on, but we know that they meet at X here. So the first thing they did was they said P, 10 minus 7 naught lies on L1. So let's just put P somewhere on here. So P is the point 10 minus 7 0 we just said, 10 minus 7 0, and now Q is going to be somewhere along here, but if I get rid of those, it's going to be the point on L2, so that PQ actually works out to be perpendicular to L2. So what that means, if I draw sort of that in, PQ, they want PQ to be at 90 degrees. So if I do that relatively accurately, then Q is going to be there. So we have that situation for, move that about, for my diagram. Okay, so if I've got that, then that's now leading me on to work out what I'm going to have to try and do here. If PQ and L2 are perpendicular to each other, what I need to do is I need to get PQ somehow. I've already got L2. The direction of L2 is what I'll be interested in, but I've already got L2. And then I'm going to show that PQ dot L2 will be equal to 0. But in order to do that, the first thing I need to do is to work out PQ. And if I'm going to work out PQ, the first thing I need to do is to just say what Q is. So I'll do it by the side of the diagram here. So if Q is on L2, then we can say OQ, we can say the position vector of that is generally given by 2 plus 2 mu minus mu and minus 9 minus 3 mu. Now, if I want PQ, something that I always tell my students is really, really helpful when we're doing this, is if you have any sort of situation here, and if you have P and if you have Q, PQ always works out to be Q minus P. It always works out. If I want PQ down there, it's always going to be minus that one plus that one. So in other words, Q minus P. So I've done that really quickly because I would be very disappointed if any of my students did anything other than to say straight away, PQ is Q minus P, or rather is 2 plus 2 mu minus mu and minus 9 minus 3 mu. And handwriting's not particularly good there. Minus P, minus 10, minus 7, 0. Really helpful if at this stage of going through doing all the algebra, you're not spending any time worrying about the very simple geometrical properties there. So what does that work out to be? That works out to be 2 mu minus 8, 7 minus mu, and minus 9 minus 3 mu. So that's PQ. And we've said, or I said a little while ago, PQ dotted with L2 is going to be equal to 0. But what do I mean by L2? I haven't really spent any time talking about this. When I've got this equation here, this is any point on the line but this vector here is the direction of the line. The same would be true for the top equation as well. So when I'm talking about the direction of one of these lines, I'm going to use either that one, or in this case, I'm going to be using 2 minus 1 minus 3 for L2. So when I'm doing that dot product now, I can say 2 mu minus 8, 7 minus mu, and minus 9 minus 3 mu. That dotted with 2 minus 1 minus 3, was it? Let's just go back and check. 2 minus 1 minus 3. That dotted with 2 minus 1 minus 3 should equal 0. And what that now means is that I'll be able to work out what mu is going to be from all this. If we actually go through and solve that, I'm going to get 4 mu minus 16. I'm going to get minus 7 plus mu. I'm going to get plus 27 plus 9 mu works out to be equal to 0. And if I then tidy all of that up, I'm going to get 14 mu, and I'm going to get minus 23 plus 27, so that's plus 4 equals 0, which gives me that mu will work out to be minus 2 over 7. Go back and just check the question. The question said, can we calculate the coordinates of Q? So if we want to calculate the coordinates of Q, we then want OQ. So OQ, if you remember, OQ we had earlier on here. OQ is that one there. In fact, I'm just going to take that. Just put that in to speed up the video here. So OQ is equal to that, with mu being minus 207, minus 2 over 7. So that means that the vector will work out to be 10 over 7, 2 over 7, minus 57 over 7, if you put it all in, but almost the opposite of the previous one, we want the coordinates this time. So that's going to be 10 over 7, 2 over 7, and minus 57 over 7 when you put all those values in. Okay, so hopefully that makes sense as a question. It's a relatively standard one that we need to go through and make sure that we practice lots of that type. Hopefully that all makes sense to you.